This is the homework question you asked about from page 222, number 37. You're looking for the points of intersection for x squared plus y squared equals 50, which is a circle, and x minus 2y equals 15, which is a line. And you were told in advance that they intersect. Around a circle, there's a lot of space. Lines can go across the plane anywhere and miss the circle, but you're guaranteed that they will hit each other. So let's see how we find out the point. First, I solve for x by adding 2y to both sides, and then I squared x to get x squared because I wanted to substitute it into x squared in the circle problem. So I FOILed 2y plus 15 times 2y plus 15 and got 4y squared plus 60y plus 225. I put that in place of x squared over here. So 4y squared plus 60y plus 225 plus the y squared from here equals 50. Then I combined like terms and got 5y squared plus 60y plus 175 equals 0. And then I divided through by 5 and got this simple quadratic equation, which I factored. I got y equals -7 and found the companion x by using the formula up here for the line. And I got 1 common -7, and I was very careful that the x, which I found later, went in the x position, and the y, which I found first, went where y goes. Then I solved for y plus 5, got y equals -5, solved for x using the same equation I used before, this one, and I got x equals 5. Again, I put the 5 here, I put the -5 here, and I have point B. So here's the A they asked for, and here's the B they asked for. Now I drew a picture with x squared plus y squared equals 50, a circle with center 0, 0, and a radius of rad 50, which I knew in my mind was about 7.1. And I didn't bother to fix rad 50 because it was my business. No one asked me to give an answer in simplest form. So I just made a circle at center 0, 0 with a radius that I pretended to be about 7. Now, I didn't graph the line exactly right. I used some sort of poetic license because the x-intercept of this line is 15, so it should be twice as far away from the circle as I put it. But I wanted to see the intersection point nicely, so I did whatever I needed to do to see the points. X minus 2y equals 15 becomes 2y equals x minus 15. I rearranged it, and then I divided by y, and I got y equals mx plus b. There's the -7.5 y-intercept, which is below the circle. Feel good about that. And this is a slope of 1/2, which is going in the right direction, although because I exaggerated the x-intercept of the line, y equals 1/2 doesn't look right. Who knew I was so popular? There was a phone call. It wasn't from the president, so we'll ignore it. Where was I? So we have a slope of 1/2 for the line, which at least looks positive and flat-ish. And now we're asked to find the midpoint of AB. Since A was 1, -7, and B was 5, -5, I added 1 plus 5 is 6 divided by 2, and I got 3, which I put over here, I guess. And then I added -7 and -5, and got -12 divided by 2 is -6, although it's pretty easy to see that -6 is exactly in between -5 and -7. Meanwhile, I found the slope. I reminded myself that the slope of AB was 1/2, which I probably shouldn't have done underneath there. I should have put this underneath there, but I'm not going to redo the whole sheet for that. So now I have M, and I have 0, 0 for the center, and now I'm going to find the slope of OM, which was delta y over delta x, which was -2 over 1. So here's -2 over 1, and here's +1 over 2, so I can conclude that AB is perpendicular to OM because the slopes of the two lines are opposite and reciprocal. This shouldn't come as any surprise to you because you learned in geometry that when you have a chord of the circle, which is what AB is, and you put in a perpendicular bisector for the chord, perpendicular bisectors of chords will always pass through the center of the circle. So we just confirmed in this particular example what we already knew to be true from 9th grade.